Hi, Assalamualaikum. My name is Nadzirah Syazwani binti Muhammad Fauzi, AA 180439. For our final year project, we decide to build and create a project that called Obstacle Avoidance Robot. For today, I will present about our project introduction, problem statement, objective, and project scope. Introduction for our project is, this project is about to build a moving robot with capability to detecting obstacle or object in its path. The implementation of ultrasonic sensor placed on the robot to detecting the surrounding object. The robot will be built using Arduino Uno board, 12-volt DC motor, ultrasonic sensor, infrared sensors, motor driver L293D, 12-volt battery, buzzer, LED, and connecting wire. The Arduino Uno used to control all the component movement. The ultrasonic sensor used to detect the obstacle either in front or by the side of the robot. The infrared sensor used to transmit an infrared signal and reflected the signal received from the object at the infrared receiver. The motor driver used to supply up to 1 ampere, hence get the information from the Arduino and make the motor work. The battery used to supply current to the motor, which in turn will make the robot move. The buzzer and LED used as a signal when the ultrasonic sensor is detecting obstacle. The connecting wire used to connect all the components together. There is a lot of problems that we find out while we are doing research based on this project. Firstly, the difficulty of every household to do cleaning floor of their house. They have to sweep every single day to make sure their house is clean from dust. The vacuum that we usually found at the store comes with a big size and it quite heavy that require a lot of energy to handle it. And we have to move it from one place to another to continue our cleaning process. The vacuum price in the market right now is a little bit costly than the convenience of the function. Sometimes it can be expensive, but the functional is not so good. The efficiency of the usual vacuum is not so efficient. For a new vacuum, it might be cleaning very good. I mean that like it will suck all the dust at your house, but later on, when after 3 or 4 years, it will start to slow down their suction, where it will not suck your dust very clean like the first time you buy it. The objective of this project is first to identify the I/O pins or input and output pins, flash size, and commands to control the robot movement. To build an obstacle avoiding robot with ultrasonic sensor and infrared sensor. Lastly, to make the sensor able to detect obstacle in its path and change their movement immediately when they detect the obstacle. The project scope of our project is, our project use Arduino Uno as the controlling element. It used an electronic sensor and 2 infrared sensors. The ultrasonic sensor used to detect the obstacle that come in the pathway and decide to avoid the obstacle by turn left or right. The 2 infrared sensors are fitted at the left and right side of the robot. The connection can be given from the main circuit to the sensor using simple cable wire. 2 motors, which are right motor and left motor, are connected to the motor driver IC L293D. The microcontroller send logic 1 and logic 0 as per the programming to the motor driver, which move the motor forward and reverse direction.
Assalamualaikum warahmatullahi wabarakatuh. My name Muhamad Idham bin Muhammad Affendi. So I will present our project from our slide. So I will present about methodology. That is from chapter 5. So at methodology section, firstly look at our project implementation. For the first, identifying problem, next analysis problem, then we start the project and create the shape of the project. So after that we start to build the project, then we select a component based on each function, and then we start to build the circuit simulation in process, and then we start the coding for the circuit and insert the coding into the circuit and test the circuit, and for the lastly we repair any error on the simulation circuit. So that is next. For the component in the circuit, that is first component is Arduino Uno. We use Arduino Uno R3, that is used as our main board that save the instruction and output for the project run. Next, we use the ultrasonic sensor, that is function to detect the obstacle that in front of it and send signal to the Arduino board to give instruction to other component. Next, infrared sensor. We use the infrared sensor to detect the impurities on the floor, even in the dark or in the daylight. This will send the signal to the Arduino board as to give them instruction to the component applies. Next, for the component in the circuit, this is L293D motor driver. This is used to supply others voltage to the motor. It have two VSS pin, that mean on for the output voltage, and another to run this component. Next, we use DC motor because this motor use 12 volt to have the idle speed. This motor is used to move the tire so that the project can be moved easy. Next, LED. We use LED to indicate the obstacle for the impurities that lies on the floor. Next, we also use buzzer because to indicate if the floor have impurities on it. It will sound when the sensor detect any impurities. So for the last component in the circuit, we use connecting wire because we want to we can connect the component with the Arduino I/O pin.
Hi, Assalamualaikum. I am Muhammad Nizaruddin bin Jumali. My number matrix is AA180822. So, for this project simulation and the result of this project, I will present it today. For the simulation, we use Proteus 8 professional software to simulate the circuit and in this project. To build the coding, we use Arduino 1.8 software version 13 to build the coding. In this simulation, for the component we use Arduino R3 board, an ultrasonic sensor, 2 units of infrared sensor, IC L293D, 2 units of DC motor, LED, and buzzer. So let's look at the simulation for this project. In this simulation, the distance is from ultrasonic sensor. VAL1 is from left infrared sensor, and VAL2 is from right infrared sensor. For the LED and the buzzer, the yellow LED is to indicate the ultrasonic sensor. When the distance is below than 20 centimeter, the yellow LED will be on. So for the infrared sensor, if the infrared sensor is triggered, the red LED and the buzzer will be on. So let's take a look at the simulation. So this is the circuit for the simulation for this project. This is the Arduino Uno R3 board. This is the microcontroller we use. This is IC L293D. This is DC motor. This is the left tire, and this is the right tire. This is the ultrasonic sensor. This is infrared sensor that at the left, and this is at the right. So this is the LED, yellow LED, that is indicate the ultrasonic sensor. The red LED and the buzzer will indicate the both of infrared sensor. This is the visual terminal. It used to see the value of the sensor. So, for the flowchart of obstacle avoidance robot, so we start. For the input, is the switch is on. If yes, the system will run. If not, the system will be not run. So if the switch is on, the output is both motor rotate forward. If yes, then they will go another input. Ultrasonic sensor detects. That means if yes, the distance is below less than 20 centimeter. If the sensor, if no, the distance is more than 20 centimeter. So if no, the output will right motor rotate forwards. That will be the system will turn left, and it will look back to below the input is the switch is on. If yes, both motor move forward. Then they will go another input. Right infrared sensor detects. That means if the if yes, the right infrared sensor is triggered. If no, right infrared sensor is not triggered. So if it is it no, so they will look back to below the input ultrasonic sensor detects. If yes, the left motor rotate forward and the right motor rotate backward. That means it will turn right. Then they will go another input. Left infrared sensor detects. If yes, the right motor rotate forward and left motor rotate backward. That means turn left. If no, it will look back to the below the input ultrasonic sensor detects. Then it will be the end of the flowchart of the system process. So let's start the simulation. Okay, when the distance is below than 20 and the left sensor and the right sensor is not triggered, so the system will turn left, that the right motor will rotate forward and the left motor will rotate backward. If we triggered the left sensor, okay, look, the left sensor is triggered, so the system will turn right. That's the right tire will rotate backward and the left tire will rotate forward. If we not triggered the left sensor and we triggered the right sensor. Let's look what will happen. Okay, look, the right sensor is triggered, so the system will turn left, that the right tire will rotate forward and the left tire will rotate backward. So what if the system will if the both infrared sensor is triggered? So let's look at this. So the both infrared sensor is triggered, so the system will reverse that the both of the motor will turn backward. So let's look what will happen if the distance is over than 20. So first we must not trigger both of the infrared sensor, and okay, we turn up the value, so the distance is got 40 cm. Look, when the both of the infrared sensor is not triggered, the system will turn forward and delay for 2000 milliseconds, and then they will turn forward again. So the right and left motor will turn forward, will rotate forward. So what if we trigger the left sensor? So the left sensor is triggered. Look, the system will turn left. The system will turn right. Sorry. The right tire will rotate backward and the left tire will rotate forward. So what if we triggered only the right sensor? Okay. Okay, the right infrared sensor is triggered. Look, the system will turn left, and the right tire is rotate forward and the left tire is rotate backward. Okay, let's look what if the both of the infrared sensor is triggered. So both of infrared sensor is triggered now. So when this mean the obstacle is right and left, but the in front of the project is not, this doesn't have any obstacle, so it will rotate forward. So the right and the both of the motor will rotate forward. So that is our simulation for this circuit.
Next, I will for the conclusion for this project. Okay, for the overall project, we can conclude that the avoiding obstacle robot project was successfully developed and operated almost as expected, because nearly every navigation robot needs the same kind of detection of obstacle. Hence, the technique of avoiding obstacles is the most important. Obstacle avoidance robot has a wide range of uses. In conclusion, obstacle avoidance is widely used and applied in the world, and most robots are likely to have a function of preventing obstacle in the future. So that's from me for the presentation of our group.